Okay, in this video, we're going to take a deeper dive into the force of time. We're going to look at the other forces, magnetism and electricity, a little bit along the way, but mostly our focus here is going to be just trying to understand more about the force of time because it's just such a complex and different sort of concept. Again, electricity and magnetism are gauge invariant. So they're sort of more about, as we think about going out into space where everything remains the same size, everything is sort of, there are these spheres all over the place, but you have things are all sort of, there's forces and powers around like the Earth, and we don't think of those things changing. If you head out to Jupiter or Venus or something like that, you think of things, our spaceships being the same size. And so you're sort of, you have a lot of different kinds of stuff going on with electricity and magnetism. But time is about this force that really goes down through spheres and from a larger whole solar sphere and down through the earth and into our brains and through our brains down to cellular and atomic levels. And so we just want to try to begin to get a deeper understanding of what time is and how it works a little bit here. We're just going to, there's so far to go with this kind of stuff, but we're going to start thinking a little bit about free will versus determinism, and then we're going to make our way into the many worlds interpretation of quantum mechanics in physics. So one of the really big philosophical debates for years has been whether there is free will or determinism. And the notion has sort of been that they must be mutually exclusive because they run in opposite directions to each other. Remember this diagram where you have science and the maternal construct, and this top, reading it from the top, you always have sort of democracy and critical thinking. And so this is the side that definitely looks at free will, and I would put with that randomness, the idea of randomness, and the notion of natural selection, which is sort of saying that you have animals that are going to get into random encounters with other problems and food things and weather and all sorts of stuff. And then there's going to be, natural selection is the processes that they go through as they try to adapt to survive for whatever challenges they're facing. And the other side of that would be determinism, which sort of it's really a reverse time concept in a way. This is also tied in with intelligent design, which has been an argument between people on the right and people on the left. What I'm here to say is I think that both are true. I think that there is free will, and I think that there is determinism and intelligent design. A quick thing you could say to the scientists to get them where they sort of almost have to agree with this, especially if people are taking my ideas about our greater life, that we are an embryo at a 6 to 8 week mark of development and developing over the next 1,000 years into a greater living being. The quick thing you can say is, does an embryo does it need to hit benchmarks in its development? And of course, any scientist anywhere would say yes. The heart starts at a certain time, the fingers separate from each other, the arms and legs grow, you get the lungs, the heart starts beating. The baby does definitely follow some sort of a pattern of hitting benchmarks as it's developing. So the idea here then is, if you have an inner civilization inside the brain of that embryo, that they have real free will, but it's sort of, in a way, to me, it sort of ends up being something like if a kid signs up for a college class and he knows he's going to have certain tests, then the the determinism is he's taking the class with this idea that at the end of the class, he wants to have a good grade in the class. And he's aiming for that as a sort of a window he has to pass through. Let's say he wants to get an A. He's a really good student. He wants to get an A in the class. But then to do that, he has free will. Is he going to go to the beach with his friends? Is he going to skip class? Is he going to play video games all day instead of doing his homework? Or is he going to do all the work to get the grade that he needs to pass that benchmark, getting a good grade so that he goes on to the next semester and the next semester and then winds up graduating and having a college degree? The daily work is sort of the free will thing. And if you don't use your free will to aim for specific goals, to build things, to create things, to keep things moving, then you're not going to hit these benchmark moments. And so, you sort of have a little bit of both, I think. So I've described the idea that you always have time as a concept, that it has a present, which is like a sphere. The sphere of the earth is our present sphere. And then you could say the inside of the earth, if there's an earthquake or something, but basically I would say that our human brains are the next smaller time, size, speed level. So the next smaller level where the future for the earth is coming from is from our human brains. So that's the sort of smaller, you can think of it as one smaller future sphere or as the many future spheres, but the idea is it's coming from this smaller level of a collection of future spheres. And then the past is out around us, the whole solar system that is built up to what it is out there. And we need to use the future energies coming from inside our brain to build in the present the spaceships and the things we need to do to go out and start to move the solar system into its future. So you get future energies that go out into the past, and I think there are past energies that make their way down and into the future. Certainly you could come up with plenty of examples, but just a giant earthquake or a comet or something that comes and hits the earth, or an asteroid or something, a hurricane, any kind of thing. So sometimes future things can come from outside of us and around us. And sometimes I think past things can come from inside of us and go outside of us. And I think these things are basically, there's an interplay between, I think natural selection is accurate as part of the picture of how things develop. But then I think that there's also a reverse time that sets up, I think reverse time comes in larger, higher energy type of unit structures or something, constructs, like me suddenly showing up with all these ideas of greater life and trying to bring about a paradigm shift to change the entire underlying reality for the human race. That's coming from my inner future, from my brain, trying to bring about a big transformative change. But when you look at the outside world, I think partly our old reality is sort of breaking down. Democrats and Republicans are at each other's throats. There's problems around the world, the debt crisis all over the place, climate change, animal die-outs, overfishing the seas, needs for fresh water and energy stuff, AI right on the verge of bringing about some sort of transcendent change if we don't organize ourselves to deal with that. And it happens first that, we face challenges there. So I think there's clearly an aspect of determinism in me showing up right at this time, as opposed to showing up 100 years ago or 100 years from now or something like that. I think there's some natural selection stuff and some determinism stuff, and these are both active and correct. Intelligent design is the mechanism sort of for determinism to some extent, the lesson I would say from all of that is like this kid in school, if there are benchmarks, you don't go through those benchmarks automatically. You have to work and prepare to be ready to go through those benchmarks. So if we are at a 6 to 8 week mark now, and we're saying that in about 1,000 to 1,200 years or so, that's the 9 months of our greater mother's greater life. That's when we're due to be born, sometime in a little over 1,000 years or so. Then we can figure out what the human benchmarks are, and we can start to figure out what kind of stuff we need to do in here. Although I think there are differences as well. But so one question is, how many different types of time are there? What are we getting into more of a physics concept here? What are we looking at? I think proton time has the time quark is an up quark, and up quark is positive time, and we've said positive time creates the past. And so everything that is out there that exists is sort of come from protons build-in structure. And so by building in the past, you build in the structure that's there. And then the future has to sort of work around the planets, the oceans, whatever is there, whatever the structure that's come from the past or from the proton. So the neutron has a down time quark, negative quark, and that means that's the future. So here we've already sort of just been going over some of the ideas of how the interplay between future and past. And remember, however big our solar system is around us, where it would be a strong past construct, it's going to be just a tiny little future construct to some much larger time, size, speed level. Everything repeats, and so you're going to have one kind of energies that may push outward at one level, and then those are going to have some other energies that go in a different direction, pushing inward. I mean, it gets vastly complex. But think about, okay, I said in an earlier video that I had something that the physicists were going to kind of really think was cool, and this is what that is. I'm going to talk about that here. So first, setting it up, we know that our DNA has genes, and these genes build proteins. And proteins are sort of like human beings. They take on jobs, and they do all kinds of jobs to make your cells healthy. And then as the cells interact and trade and move stuff around in your blood and all the things moving through your blood and everything, all of that comes from a large number of all of these different kind of proteins, which are sort of like different career specialties or something, which the proteins do, moving things, destroying things, building things, just jobs. They do work. They do the work of the whole system. And the DNA, so they're sort of human-like, and the DNA is sort of computer-like. It's where everything gets figured out and then builds the proteins. Which, of course, you can say, well, we humans are building the computers. The computers aren't building us. We're building the computers. Well, we may have been built by computers inside the sun. Our DNA is inside the sun. It built us. Now we start the process of building computers, which will build the next larger level of humans. So if we're going to become alive as a greater human being, so it's sort of like this, something like that. Okay, now the part the physicists will like. So go down to the subatomic level. And at the subatomic level of existence, the physicists talk about the particle zoo. And you have all these different kind of subatomic particles. A handful of them are the really main ones that we hear about all the time. Photons, gluons, neutrinos, electrons, and then the larger size equivalent ones. But those are 4 of the big ones. But there are all kinds of, kaons and pions and mesons and this whole giant particle zoo. Well, so I think the particle zoo is level jumping down. It's the same thing. Subatomic particles are created by, what you could call atomic level DNA. they are the physical particles that are like proteins, which are like humans. So the particle zoo are jobs that are physics jobs, subatomic jobs, jobs that build the physics so that they can build the cells, and within the cells build the proteins, so that they can build humans and computers to keep the whole process moving upward. So look at this diagram here. Okay, first, just a massive oversimplification. Everything here is a very great simplification, but let's say magnetism is the thing that gives push and pull energies. The electric force is the thing that gives communication, the brain energies. And then time is the thing that gives things mass. And so if you look at the rainbow-colored hexagon there, that is not the cultural rainbow. This is my new logical system. This is a critical part of both the proton and neutron. We'll get into it more. But look at the red, yellow, and blue triangles as pointing upwards. So these are the blade concepts. They build the land. They build physical structure. They are core energies that build upwards. So if we humans are trying to build into the solar system, we would have red, yellow, blue energies trying to take on responsibilities for building upwards. The green, violet, orange are antimatter in a sense that gets turned into the gravity energies. They push down, squeeze down on the blade energies. So they are sort of like gravity energies that are pushing against and working against, to some extent, the energies that are pushing up. So look at the start code then. And the start code, this is an idea for a subatomic, what you would call a subatomic codon. You can see the DNA, down below there. You have a codon with 3 sets of nucleotide pairs, and those build an amino acid then, and then an amino acid connects to another amino acid and another to build proteins. But so the start code, we're looking at one single amino acid or codon, and we're saying that in its true form, you would have a true magnetism as red, a true electric as yellow, and a true time factor there as blue. And the rules are those 3 colors are not allowed to exchange places with each other. It would be like saying you were going to put a Republican man into a Democratic man's spot and say it was the same thing. It's not. They're completely different. And so they cannot, yellow has to go where yellow goes, red with red, blue with blue. They can't change. But you're allowed to use the 3 opposites to get, those are, with a DNA, you have 4 choices for each nucleotide position. And so there would be, this is saying you have one true position and then a choice of 3 opposites. And so if you look at the photon, for example, with a photon, they know that when it travels, it has a magnetic wave and it has an electric wave, and there is no time wave. And so you look at it and you say, okay, well, it probably has the true magnetic factor and a true electric factor. That's what gives it its basic electromagnetic, the 2 combined making up the wave. But then it must turn its time factor, the bottom one, into something else. And so assuming here a photon would probably have too much magnetism, and that would be something other. The photon, we think of it as a main carrier of the electric force, so it just makes sense. And the only option is an opposite electric, which is sort of saying you're taking the time factor and you're putting the opposite gravity. You're taking something that pushes down from the outside instead of something that pushes up from the core, but you're taking, in essence, a neutral position, if you're using the opposite electric. I mean, we'll be going a lot further into interpreting this sort of stuff. With the gluons just hold things together. and that just sounds like magnetism. That's what, we've talked about how in Washington, D.C., the brains of the senators and the representatives hold the states together. That's the main thing. So you're putting an opposite magnetism in the electric spot and an opposite magnetism in the time spot, and you're just getting a little glue ball that's going to sit there and really hold something together. Same with the neutrino, is a time particle. It does not carry the electric force, and it has so little mass that if you have the true time and then two opposite times, it's like saying you have a particle that has mass, but it's got super strong gravity, double gravity around it. So it's going to make it very small and reduce the mass way down to the tiny level. So that's an idea. I mean, you physicists will have to look at this and say, and maybe I'm wrong about that. Maybe the neutrino has an electric or a magnetic or something. But these are just some quick ideas. But I think that using this methodology, you can begin to look at your entire particle zoo, and we can carry this up and begin to get a much better understanding of how, codons and DNA language and proteins and amino acids and everything are built by understanding this same structure. Okay, so I think that's sort of fun and that's interesting. But now look at this diagram. We're studying here, we're just trying to look at just time for the moment. So the black holes that I show, that's so you can still see what's what, but anything with a black hole in it is just saying that's not what we're studying right now. We're only looking at the time force in this diagram. So just the blue and oranges. But so in our star code, in our original one, you have the true time that's with an electric and a magnetic. Okay, and so if it's set up as the start code like this, with the true time factor in place, then there's three other options that it could have. It could have an opposite time in the electric spot, it could have an opposite time in the magnetic spot, or it could have both an opposite time for the magnetic and for the electric. But then if its time factor also switches, so that it has an opposite time there as you see on the top there, then it also has three other options. So there's 8 total options, and each one of these would show up as some sort of opposite time. If you think of the true time as being something diffusive, something that pushes up, and opposite time as something that squeezes down, well, when you make these changes into the magnetic spot, into the electric spot, when you double it up, so both the magnetic and the electric, or if you have the opposite time then with some of these other changes, these are inside our bodies, all the particles inside of us. You're going to have the same thing with the electric, 8 options for the different electric possibilities, 8 options for the different magnetic possibilities. There are 64 possibility. The way our DNA is, with the 4 nucleotides in the same setup here, you have 64 total possibilities. But for we humans, they think there's only about 20 amino acids that really, they set up forms that are sort of repetitive with each other. And so there ends up being essentially different ways of making lysine or glycine or something like that. But for the most part, there's about 20 of them that are really active, separate amino acids that play really different roles inside of us. So you can take the concept that from the proton you've got the future mostly on the inside of a smaller level, which is technically the time is running slower, but again, counterintuitively, everything's running much quicker. So if an Earth is spinning, 1 million times for one of our outer rotations, an inner civilization is going to get ahead of our outer civilization. the future. If you went down in a spaceship, an imaginary spaceship, you'd be going down into something in a far future reality, whereas outside of us is all would generally be a past reality, something that is where we here on the surface of the earth are ahead of the rest of the big solar system out around us. But so, as well as having that past and future, but we know that there is some past in the smaller level, we know there's some future at the larger level. So just along with that construct, fairly simple construct arising from proton sort of doing the past energies and neutrons sort of doing the future energies, now you really have to think of that through every unit of how proteins are created. And now we're seeing even how subatomic particles are created. And this is going to be how we humans are made if we're like greater proteins. And as we go out into the solar system, what forces and factors are going to be working on us. You really have 8 different kinds of magnetism, 8 different kinds of electricity, and 8 different kinds of time, which is sort of interesting. Look at this diagram. I say there's an incorrect time wave and a correct time wave. This is when physicists think about a particle moving through space. So the white arrow is the direction of propagation of an electromagnetic particle, and the blue circles there are adding a longitudinal time force. And I think the physicists have showed it with the incorrect diagram. It's sort of like the time is sort of like a slinky that's about the same size, and it'll bunch up with more energy here and then spread out through another space and then bunch up again. But I think if you look at the white arrow on the right part of the diagram as being as representative of a smaller time size speed level. So what you see on the outside there, you're going to have that same set of dynamics all inside the line as the line is traveling along the line of propagation. And the outside of the 2 largest blue circles that you see there, the outside, sort of like a submarine that pings out its radar, and the radar sort of goes out from the submarine to some furthest level area. That would be the next larger propagation of motion of another white arrow, where the particle is going somewhere at a larger level. So I think the time energies, instead of moving sort of back and forth along the propagation of motion, I think they're coming up from a smaller level to a larger level and then coalescing back in. And so that's a diffusive process of coming out and then a coalescent process of going back in, sort of like male, female, or something like that. Okay, so let's transition towards putting all this together a little bit with the many worlds interpretation, which was figured out by a guy named Hugh Everett back in the 50s or something. What in quantum mechanics, they had this idea that you collapse a wave function, and when you collapse a wave function, something happens. You've made a decision or a choice has been made, and so some aspect of reality comes into existence, and then whatever the other possibilities could have been, whatever the other choices could have been, just disappear. And there's a lot, there gets to be philosophical problems and stuff with that. And so arising from what the Schrödinger equation says about how all of this works very specifically, is another interpretation became this many worlds interpretation. And what it says is, instead of a wave collapse, what happens is you have both possibilities. Because there's a lot of entanglement of everything, you're not really choosing one thing completely or another thing. You're having a splitting of reality into 2 realities. And then when another action of some sort happens, another choice is made, something that would be a wave collapse, but now you're interpreting it differently, you have another splitting of realities. And so the way I would describe this is you have this idea of Hilbert space. This is this mathematical vector space that can become these an infinite number of realities. And a way to describe that is, let's say you have this sphere and you have an arrow coming into the sphere, that if it is coming in at a unique vector designation into the Hilbert space, then that means it's coming from another reality in essence. So you can show another reality that is attached with that arrow going into the vector space. And if you have another arrow that's also unique, then that creates another reality. And if you have another arrow, then that creates a third reality, and it goes on infinitely, theoretically. But when there's a singularity function, this causes problems with the conservation of energy. So there's an idea that when there's a singularity function or a supermassive black hole, that this limits the amount of total realities that you can have. But I would say also, we studied in an earlier lecture how every particle with mass, every half-spin particle, is connecting two 360-degree realities. You have the particle reality that's connected to the electric or the negative reality. And so you never have, just like you never have a magnetic monopole or something, you're never going to have a pure Hilbert space that is not connected to the real world to some extent. And so that's also going to cause conservation, even more, probably more strong conservation of energy problems. But so let's just think about this differently for a minute. Imagine that the many worlds interpretation is correct. It's sort of shown us how it works. But imagine that what it really is a mechanism built by the whole multiversal physics, God, whatever construct of existence for problem solving. If you have an outer reality and it is facing some sort of problem and it's gonna die. If an animal is being hunted by another animal, it has to come up with a solution for that problem, or it's dead. And if the human race doesn't figure out, climate change or die out of animals or fresh water stuff, we are facing a lot of existential big crises. If we don't solve these problems, human race is dead. Any kind of entity, any larger time, size, speed level of some kind of organization of life needs solutions. So what does it need for that? It needs this concept of these many smaller future spheres. So think of a woman. If you have an idea that, okay, a woman's body can create these egg cells, which are new realities, imagine that it's the many worlds interpretation that creates them to have this number 100 billion. And it's the conservation of energy where she's not creating 100 billion outside herself at her same level. She's creating them inside of her at a much smaller time, size, speed level. So if she gives birth to a whole new inner civilization, it's going to have these time factors. But imagine, I don't know if I'm saying this right. Let's just picture a brain that is facing a problem. And imagine that what happens is this causes the inner computers inside the brain to build a new reality construct, maybe inside a proton or inside a neutron or something, and it's going to have this 100 billion number associated with, just like our human brains do. And so as time plays out, you have this future group, but moving at this much faster time. So they're going to solve the problem, and then it would get worked up into the whole brain, which then goes to solve the problem for the outer reality. I mean, you kind of get what I'm saying with this. I'm not saying this, I have not said this part as well as I'd like, but I think the many worlds interpretation, You say, why the number 100 billion? Well, I would think of that probably just as a cost analysis, that the computer side of nature, the whole physics side, if you try creating a reality with 10 billion possibilities or 10 billion different things that are trying to find solutions to something, that may not be a large enough number to reach the solutions that you really need. But if you have a trillion of these little smaller spheres, a reality with a trillion people, say, all working on a problem, that may just be way more than you need. But about 100 billion is probably been determined through trial and error, through existence, as about the right number, that if each different, miniature brains, or this would be inside a cell, you have the DNA with about 100 billion atoms making up the total of the 23 paternal chromosomes, and then about 100 billion making up the maternal chromosomes. And so if all of those are sort of working together, the 100 billion, that may be enough for them to come up with the proper genes, to come up with the proper proteins, to go out and solve the problem, which then can, move up to us humans getting ideas to solve problems for the solar system or something. I mean, I think the many worlds interpretation doesn't create realities outside of you at your same time, size, speed level. I think that it creates much smaller, down at the smaller time, size, speed level in the future. And then the solutions eventually work their way up. And so this is how existence moves forward. This is how our multiverse is evolving forward, and this is how the human race is solving the problems around us, and how we're going to figure out all the things that we need to bring the solar system into life. So thank you very much. I'll see you in the next video.